www.ruralnaukri.com। न्यूज़ पोर्टल का प्रयोग कर नौकरी ढूंढना। अपने वेब ब्राउज़र के एड्रेस बार में www.employmentnews.com टाइप करें। होम पेज पर महत्वपूर्ण सूचनाओं व लिंकों से युक्त
Hello students, welcome to the topic of making of small wall bracket frame. At the end of this exercise, you shall be able to mark and make the small wall bracket frame.
Materials, tools and equipments: table saw, router tool, chisels, mallet or hammer, measuring and marking tools, wooden mallet or block, marking gauge, jack plane, steel tape, wing compass, hard or teak wood and plywood. Process: side pieces. Check the work pieces for the required measurements. Side pieces 200 into 30 into 400 to 2 numbers using folding rule. Plane the pieces to the required width and thickness using jack plane. Size 180 into 25 into 330 mm is equal to 2 numbers. Mark the dimensions on the surface of the side pieces. Set the wing compass and mark the convex lines on the surface of the side pieces. Adjust the wing compass and mark the concave line on the surface of the job to get continuation with marked convex lines. Lining piece. Check the work piece for the required measurements 50 into 25 into 500 to 1 numbers. Plane the piece to the size 35 into 20 into 460 mm is equal to 1 number. Mark the dimensions of the lining piece profile. Top piece. Check the work piece for the required measurements. 100 into 25 into 500 is equal to 1 number. Plane the piece to the required size 75 into 20 into 430 mm. Mark the dimension of the top piece profile. Bottom piece. Check the workpiece for the required measurements. 175 into 25 into 500 is equal to 1 number. Plane the piece to the required size 150 into 20 into 430. Mark the dimensions of the bottom piece profile. Back piece. Check the workpiece for the required measurements. Prepare 430 into 220 into 6 mm plywood as per dimension of the table for fixing on the back side of the frame.
In this video, we learn how to mark and make a small wall bracket frame. Hello students, welcome to the topic of making of shelves by 6 pieces with single half lap dovetail joint and assemble with small wall bracket. At the end of this exercise, you shall be able to make the half lap dovetail, make the rebate and assemble and finish the wall bracket.
Materials, tools and equipments. Sandpaper, wood screw, wood glue, router tool, chisels, mallet or hammer, measuring and marking tools, screwdriver, drilling machine, bar clamp, wooden mallet or block, sanding tools, finishing supplies, dovetail saw, marking gauge. Process. Mark and make the single half lap dovetail socket on the side piece's top. Mark and make single half lap dovetail pin of the lining piece. Assembling and finishing. Apply the glue on the shelves by 6 pieces on the surface topped mortise, tenon and single half lap dovetail socket and pin. Assemble the pieces together using mallet or hammer. Place the wall bracket over bar clamp and tighten it. Drill a hole on the marked point of the drill hole using per table power drilling machine. Screw the side together using 35 mm screw. Drive the screws so that screw head should sit properly in the counter sink holes. Screw the lining piece on top of the side pieces with 35 mm screw using screwdriver. Fix the 6 mm plywood on rebate surface of the frame using 20 mm wire nail. Check the squareness of the job. Smooth the surface of the wall bracket using sandpaper number 60, 120, 150. Finish the small wall bracket.
In this video, we learned how to make shells by 6 pieces with single half lap dovetail joint and assemble with small wall bracket. Hello students, welcome to the topic of making of 4 sides of chalk box tray with common dovetail joint. At the end of this exercise, you shall be able to make 4 sides of chalk box, mark a common dovetail joint.
Materials, tools and equipments. Portable power circular saw machine, chisels, mallet or hammer, measuring and marking tools, wooden mallet or block, dovetail saw, marking gauge, jack plane, 4-fold wooden rule, hardwood. Process. Check the wooden pieces for its size using measuring tape. 210 into 25 into 410 mm is equal to 2 numbers. 210 into 25 into 610 mm is equal to 1 number. Plane the material to size using jack plane. 200 into 20 into 410 mm is equal to 2 numbers. 200 into 20 into 610 mm is equal to 1 number. Mark the measurements of side pieces 400 mm, 400 mm and square the edges and smoothen it using firmer chisel. Mark the measurements of front and back piece to the length 300 mm, 300 mm with cutting allowance. Cut the front and back plank to the length of 300, 30 mm and square the edges and smoothen it using firmer chisel. Make one plank of size 185 into 20 into 300 is equal to one number for front side.
In this video, we learn how to make 4 sides of chalk box tray with common dovetail joint. Hello students, welcome to the topic of making of the lid with handle for chalk box. At the end of this exercise, you shall be able to make the lid with handle.
Materials, tools and equipments: sandpaper, wood screw, wood glue, hardwood, plywood, portable power circular saw machine, chisels, mallet or hammer, measuring and marking tools, clamps, wooden mallet or block, sanding tools, dovetail saw, screwdriver, drilling machine with bit and bar clamp, marking gauge. Process: check the wooden pieces for its size. Plywood 400 into 300 into 5 mm, one number. Teakwood 50 into 25 into 210 mm, one number. Plane the plywood size of 390 into 280 into 5 mm for thelid. Plane the teak wood reaper of size of the 45 into 20 into 210 mm. Take the teakwood reaper, cut it to a length of 200 mm for the handle piece. Mark and make a drill hole for the handle piece. Apply Fevicol on the plywood lid of size 390 into 280 into 5 mm in the front edge only. Affix the handle reaper 45 into 10 into 200 mm as shown in the sketch 1 and drive the screw using the screwdriver on lid. Check the squareness of the lid and handle. Smooth the surface of the lid using sandpaper.
In this video, we learn how to make the lid with handle for chalk box.
Hello students, welcome to this trade on woodwork technician carpenter. A woodwork technician, commonly known as a carpenter, is a skilled professional specializing in woodworking and carpentry. These individuals are essential in various construction and renovation projects where their expertise is crucial in crafting and installing wooden structures, components, and finishes. Carpenters work with a diverse range of materials, including different types of wood, composite materials, and other related products. In this session, we are going to learn about plan for making a desired modular kitchen cabinet. Objectives. Planning for making a desired modular kitchen cabinet involves a systematic approach to designing a functional, efficient, and aesthetically pleasing storage solution for the kitchen space. This process entails careful consideration of various factors, including space constraints, storage needs, design preferences, and budgetary constraints. By the end of this course, you will be able to space assessment and layout, storage needs and organization, material selection and durability, aesthetic elements and style, user-centric design. Planning a desired modular kitchen cabinet involves the consideration of various tools and equipment to ensure accurate measurements, precise design, and efficient workflow. Here's a brief introduction to some essential tools and equipment used in the planning phase. Graph paper or sketchbook, pencils, erasers, and pens. Measuring tape, computer or laptop for digital design work, reference materials, budget spreadsheet, notebook or planner, samples of finishing materials, online resources. Now, let us see the preparations needed for the plan and making the desired modular kitchen cabinet. Few points to remember before making a cabinet. Planning for a modular kitchen cabinet entails several crucial preparations to ensure a smooth and efficient execution. Firstly, meticulous measurements of the kitchen space are essential to accurately design the cabinet layout. Secondly, thorough research into various materials, finishes, and hardware options is necessary to select the most suitable components. Additionally, budget allocation and timeline setting are vital for project management and cost control. Detailed sketches or blueprints should be drafted to visualize the cabinet's design and functionality. It's also important to consider any electrical or plumbing requirements that may affect the cabinet's installation. Lastly, consulting with professionals or seeking advice from experienced individuals can provide valuable insights and guidance throughout the planning process. Task 1. Preparations needed for plan for making the desired modular kitchen cabinet. Clearly outline your specific needs and preferences for the modular kitchen cabinet, considering storage, style, and functionality. Determine a realistic budget for the project, accounting for materials, labor, and any additional features or accessories. Measure the kitchen space accurately, noting the location of doors, windows, and other fixed elements that may impact the layout. Gather information from various sources, creating a collection of images that represent your desired style. Evaluate the current kitchen layout, identifying any inefficiencies or areas for improvement in terms of functionality. If needed, consult with a professional kitchen designer or architect to gain valuable insights and expertise. Research and decide on the materials for cabinet construction, countertops, and finishes based on durability and aesthetic preferences. Gather specifications for any specific appliances or fixtures you plan to incorporate, ensuring they fit seamlessly into the design. Establish a realistic timeline considering ordering materials, construction, and installation. Summarize your requirements, preferences, and key features in a design brief for reference during the design process. Assess the existing lighting in the kitchen and plan for adequate task lighting, considering under cabinet lighting for better visibility. If the project involves relocating electrical outlets or plumbing fixtures, plan for these changes in the initial design. If sustainability is a priority, explore eco-friendly materials and practices for cabinet construction. Factor in your daily routines, cooking habits, and family lifestyle when planning the cabinet layout to enhance practicality. Now let us see the process for planning and making desired modular kitchen cabinet. Few points to remember before assessing kitchen cabinet materials and accessories. Exploring kitchen cabinet materials and accessories opens a realm of possibilities for enhancing both functionality and aesthetics in the heart of your home. Diverse materials like hardwoods, laminates, and metals offer unique characteristics in terms of durability, style, and maintenance requirements. Choosing between traditional or modern styles, as well as considering factors like color schemes and texture, can significantly influence the overall design ambience. Accessories such as handles, knobs, and hinges not only serve practical purposes but also contribute to the cabinet's visual appeal. Innovative storage solutions like pull-out shelves, lazy Susains, and drawer dividers optimize space utilization and organization within the cabinets. Understanding the diverse array of materials and accessories empowers homeowners to craft personalized and efficient kitchen space tailored to their lifestyle and preferences. Task 2. Kitchen cabinet materials and accessories. Referring to the drawing specifications is essential before embarking on the planning and design of the desired modular kitchen cabinet. A thorough understanding of the details outlined in the drawing is crucial for a successful execution. Once the drawing specifications are comprehended, calculate the required size of plywood for the cabinet, ensuring precision and adherence to the specified measurements. Additionally, determine the necessary quantity of sunmica for both the interior and exterior of the cabinet. Accurate calculation of cabinet basket and sliding rail. When selecting hinges for the cabinet, carefully choose the appropriate shape and size to ensure a seamless fit. Subsequently, cut the plywood according to the designated measurements, taking into account the specified quantity. Incorporate a well-suited handle for the cabinet and consider the ideal side for placement before fixing the hinges. Similarly, mark and cut to accommodate the sink, aligning with the drawing specifications. Take note of the granite size and color details to facilitate proper planning and coordination. Calculate the necessary amount of Fevicol and other adhesives, ensuring secure and durable construction. Evaluate the requirement for banding edge tape and meticulously note the size, type, and quantity of screws needed for assembly. For any glass components outlined in the drawing, calculate the appropriate size and select the suitable glass corner holder. Additionally, note the size and quantity of magnetic cabinet latches to ensure proper closure. Throughout the process, it is crucial to determine the most suitable site for various elements such as fixing the sink, fixing the hinges, and finalizing the placement of handles. This meticulous planning and attention to detail will contribute to the successful realization of the modular kitchen cabinet design. In this trade, we have learned how to do space assessment and layout, storage needs and organization, material selection and durability, aesthetic elements and style, user-centric design. I hope you all understood the plan for making the desired modular kitchen cabinet. Thank you, students, and let us meet in the next session. Bye. Hello, students. Welcome to this trade on woodwork technician carpenter. In this session, we are going to learn about preparing layout for kitchen cabinet structure. Preparing the layout for a kitchen cabinet structure is a crucial step in the design process, ensuring that the final installation aligns with both functional and aesthetic considerations. This phase involves creating a detailed plan that outlines the arrangement of cabinets, countertops, and other elements within the kitchen space. A well-prepared layout takes into account the dimension and features of the kitchen, considering factors such as doorways, windows, objectives. The primary objective of preparing the layout for a kitchen cabinet structure is to design a space that optimizes functionality, meet the specific needs and preferences of the users, utilizes available space efficiently, and achieves a harmonious and aesthetically pleasing design. By the end of this course, you will be able to measure the kitchen space accurately, including dimensions, doorways, windows. Develop a preliminary sketch or draft of the kitchen layout. Design the layout for the wall-mounted kitchen cabinet unit. Create the layout for the base unit of the kitchen cabinet. Create a detailed and accurate technical drawing of the final layout. The process of preparing a layout for kitchen cabinet structure requires the use of various tools and equipments to ensure precision, efficiency, and accurate visualization. Essential tools and equipment required for preparing layout for kitchen cabinet structure are listed below. Tools and equipments: graph paper or sketchbook, pencils, erasers and pens, measuring tape, computer or laptop for digital design work, reference materials, budget spreadsheet, notebook or planner, samples of finishing materials, online resources. Preparing the layout for a kitchen cabinet structure involves several essential preparations to ensure a well-organized and functional design. This phase requires meticulous attention to detail, understanding the available space, and aligning the design with the specific needs and preferences of the user. Advantages of modular kitchen layout. Compile a list of necessary materials for crafting and modular kitchen. Clearly comprehend the positioning of the base unit and wall unit. Choose the specific type of modular kitchen that suits your requirements. Simplify the process of assembling the modular kitchen cabinet. Determine the appropriate type of joints to be used. Facilitate subsequent checks and inspections of the modular kitchen. Minimize the overall expenses associated with cabinets construction. Simplify the calculation of the modular kitchen cost. Significantly reduce the likelihood of errors in the construction of the modular kitchen. Points to remember before preparing layout for kitchen cabinet wall unit. Preparing for the layout of kitchen cabinet wall units involves several crucial steps to ensure optimal functionality and aesthetics. Firstly, accurate measurements of the kitchen wall space should be taken to determine the available area for cabinet placement. Secondly, consideration should be given to factors such as the placement of electrical outlets, switches, and plumbing fixtures to avoid any interference with the cabinet layout. It's essential to assess the kitchen's workflow and storage needs to strategically position the cabinets for convenient access and efficient usage. Creating a detailed sketch or blueprint of the proposed cabinet layout help visualize the design and identify any potential issues before installation begins. Additionally, selecting suitable materials, finishes, and hardware for the wall units is crucial to achieving the desired style and durability. Lastly, consulting with a professional or utilizing design software can provide valuable insights and assistance in optimizing the layout for both practicality and aesthetic appeal. Task 1. Layout kitchen cabinet wall unit. Backpiece. Lay out the backpiece of cabinet considering the sawing edge planning and sunmaker bonding allowances. 2100 into 600 mm 1 number. Side vertical piece. Lay out the vertical pieces of cabinet considering the sawing edge planning, sunmaker bonding and edge bonding, tape bonding allowances. 220 into 560 mm 4 numbers. Top horizontal piece. Lay out top piece of cabinet considering the sawing, planning, sunmaker bonding and edge bonding, tape bonding allowances. 280 into 800 mm 2 numbers. Bottom horizontal piece. Lay out the bottom horizontal pieces of cabinet considering the sawing, planning, sunmaker bonding and edge bonding, tape bonding allowances. 220 into 800 mm 2 numbers. Middle horizontal piece. Lay out the middle horizontal pieces of cabinet considering the sawing, planning, sunmaker bonding and edge bonding, tape bonding allowances. 220 into 760 mm 2 numbers. Door piece. Lay out the door pieces of a cabinet considering the sawing, edge planning, sunmaker bonding and edge bonding, tape bonding allowances. 400 into 580 mm 4 numbers. Creating an effective layout for kitchen cabinet base units is a crucial step in achieving a functional and visually appealing kitchen design. The layout serves as the foundation for optimizing storage, ensuring efficient workflow, and enhancing the overall usability of the space. Points to remember before preparing layout for kitchen cabinet base unit. Preparing the layout for kitchen cabinet base units involves several key steps to ensure a functional and well-designed space. Begin by accurately measuring the available floor area where the cabinets will be installed, taking into account factors like doorways, windows, and appliances. Consider the kitchen's workflow and designate zones for cooking, food preparation, and storage to optimize usability. Assess storage needs and select cabinet configurations that maximize efficiency, such as deep drawers or pull-out shelves. Choose materials, finishes, and hardware that align with the kitchen's aesthetic and style preferences. Create a detailed layout plan either through consultation with professionals or utilizing design software to visualize cabinet placement and ensure a seamless fit within the space. Task 2. Layout kitchen cabinet base unit. Back piece. Lay out the back piece of a cabinet considering the sawing, planing, and sunmaker bonding allowances. 750 into 2100 mm, one number. Side vertical piece. Lay out the side vertical pieces of a cabinet considering the sawing edge planing, sunmaker bonding, and edge bonding, tape bonding allowances. 520 into 730 mm, two numbers. Middle vertical piece. Lay out the middle vertical pieces of a cabinet considering the sawing, edge planing, sunmaker bonding, and edge bonding, tape bonding, and tape bonding allowances. 520 into 19 into 634 mm, three numbers. Top horizontal piece. Lay out the top horizontal piece of cabinet considering the sawing edge, planing, sunmaker bonding, and edge bonding, tape bonding allowances. 575 into 19 into 2100 mm, one number. Bottom horizontal piece. Lay out the bottom horizontal piece of a cabinet considering the sawing edge, sunmaker bonding, and edge bonding, tape bonding allowances. 520 into 19 into 2060 mm, one number. Bottom vertical piece. Lay out the bottom vertical piece of cabinet considering the sawing, edge planing, and sunmaker bonding allowances. 2060 into 19 into 76 mm, one number. Middle horizontal piece. Lay out the middle horizontal pieces of cabinet considering the sawing, edge planing, sunmaker bonding, and edge bonding, tape bonding allowances. 520 into 760 into 19 mm, one number. 520 into 370 into 19 mm, one number. Basket piece. Lay out the basket pieces of a cabinet considering the sawing, edge planing, sunmaker bonding, and edge bonding, tape bonding allowances. Door piece. Lay out the door pieces of a cabinet considering the sawing edge, planing sunmaker bonding, and edge bonding, tape bonding allowances. 390 into 660 mm, 2 numbers. 400 into 660 mm, 2 numbers. In this topic, we have learned to measure the kitchen space accurately, including dimensions, doorways, windows. Develop a preliminary sketch or draft of the kitchen layout. Design the layout for the wall-mounted kitchen cabinet unit. Create the layout for the wall unit and base unit of the kitchen cabinet. Create a detailed and accurate technical drawing of the final layout. I hope you all understood the process for preparing a layout for kitchen cabinet structure. Thank you, students, and let us meet in the next session. Bye. Hello students, welcome to this trade on woodwork technician carpenter. In this session, we are going to learn about making the material as per cabinet layout and check the dimensions. Making the material for kitchen cabinets involves creating components such as cabinet doors, drawers and panels according to a carefully planned layout. This process includes taking accurate measurements and checking dimensions to guarantee a seamless and visual appealing installations. Objectives. The objectives of this trade is to accurately cut materials according to the kitchen cabinet layout, ensuring precise dimensions, minimizing waste and promoting cost-effective production for a seamlessly integrated and visually appealing cabinet installation. By the end of this exercise, you will be able to achieve precise dimensions by cutting cabinet materials accurately, minimizing errors, and optimizing material utilization. Follow the kitchen cabinet plan carefully, making sure all parts fit together smoothly for a neat and good looking setup. Cut materials to specified dimensions, minimizing waste and promoting cost-effective production. Implement thorough checks to verify dimensions, identifying and rectifying any discrepancies in the manufacturing process. Let us now take a look at the tools, equipment and consumables needed for making the material as per cabinet layout and check the dimensions. Task 1. Kitchen wall unit cabinet required material 19 mm thickness plywood. Back pieces 2100 into 600 mm 1 number. Top piece 800 into 300 mm 2 number. Bottom piece 800 into 240 mm 2 number. Door piece 600 into 1600 mm 1 number. Middle piece 1600 into 300 mm 1 number. Vertical piece 1200 into 600 mm 1 number. Half white sunmica 0.8 mm thick. Back piece 2110 into 610 mm 1 number. Top piece 810 into 310 mm 2 number. Bottom piece 810 into 310 mm 1 number. Door piece 410 into 610 mm 4 number. Middle piece 810 into 250 mm 4 number. Vertical piece 1210 into 610 mm 1 number. Color sunmica 1 mm thick. Top piece 310 into 1810 mm 1 number. Bottom piece 310 into 1810 mm 1 number. Door piece 610 into 1810 mm 1 number. Vertical piece 610 into 1210 mm 1 number. Back piece Front middle part 610 into 510 millimeter, 1 number. Door wide glass 480 into 310 into 5 millimeter, 2 number. Task 2. Kitchen base unit cabinet required material 19 millimeter thickness plywood. Back piece 2100 into 750 millimeter, 1 number. Top piece 2100 into 575 millimeter, 1 number. Bottom piece horizontal 2060 into 520 millimeter, 1 number. Bottom vertical piece 2060 into 76 millimeter, 1 number. Door piece 1600 into 670 millimeter, 1 number. Side vertical piece 750 into 600 millimeter, 2 number. Middle vertical piece 635 into 520 millimeter, 3 numbers. Middle horizontal piece 1200 into 600 millimeter, 1 number. Basket piece 700 into 600 millimeter, 1 number. Half white sunmica 0.8 millimeter thick. Back piece 2110 into 750 millimeter, 1 number. Top horizontal piece 2110 into 610 millimeter, 1 number. Bottom horizontal piece 2110 into 610 millimeter, 1 number. Door basket piece 2110 into 750 millimeter, 1 number. Side vertical piece 1210 into 750 millimeter, 1 number. Middle vertical piece both side 1510 into 610 millimeter, 1 number. Color sunmica 1 millimeter thick. Top horizontal piece 2110 into 610 millimeter, 1 number. Bottom vertical piece 2110 into 110 millimeter, 1 number. Door basket piece 2110 into 750 millimeter, 1 number. Side vertical piece 1510 into 610 millimeter, 1 number. Granite stone front edge make half round with sink cutting and gas hose hole cutting. Size 2100 into 600 into 25 millimeter, 1 number. Hardware Fevicol SR 8 kgs, Fevicol SH 1 kg, Fevicol Heat X 1 kg. Handle with screw 150 millimeter, 11 numbers. Full overlay frameless cabinet hinge with screwer 16 number. Magnetic door catch with screws 54 millimeter, 8 numbers. Basket 1 set, 3 numbers. Glass corner fitting 8 numbers. Edge banding tape 30 meter. Phillips flat head screw 60 into 5, 213 ox. Araldite adhesives 1 kg. Sliding rail 450 millimeter, 3 set. Required tools and machines. Steel tape rule 3 meters, 1 number. Tri-square 200 millimeter, 1 number. Wooden tri-square 600 millimeter, 1 number. Firmer chisel 30 and 50 millimeter, each 1 number. T-bar clamps 1800 millimeter, 1 number. C-clamp 150 millimeter, 1 number. Straight edge 200 millimeter, 1 number. Marking gauge 1 number. Hand saw 750 mm, 1 number. Claw hammer 1 number. Ball peen hammer 1 number. Pincer 1 number. Slim taper file 150 mm, 1 number. Center punch 5 mm, 1 number. Mallet 1 number. Oil stone 150 into 50 into 25 mm, 1 number. Screwdriver 300 mm, 1 number. Oil can 1 number. Portable power circular saw 1 number. Portable power planner 1 number. Portable power disc sander 1 number. Portable electric screwdriver. Phillips screwdriver drill bit PH5 into 65 mm, 5 numbers. Concealed wood hinge boring hole drill bit 35 mm, 1 number. Portable electric jigsaw 1 number. Portable electric drill light duty. Portable power rotary hammer drill machine 1 number. Rotary hammer drill bit 3 number. Sunmaker cutter 1 number. Glass cutter 1 number. Now let us see the preparations needed for making the material as per cabinet layout and check the dimensions. Task 1. Kitchen wall unit cabinet material. Check the raw material size as per dimension. Back horizontal piece. Mark and make the total length and width of the plywood back horizontal piece of the wall unit cabinet using portable power circular saw and portable power dish sander. 2100 into 600 into 19 mm, 1 number. Mark and make the total length and width of the half white sunmica using a sunmica cutter. 2105 into 605 mm, 1 number. Bond the half white sunmica on inside surface of the back vertical piece using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmica edge using portable power planner. Side vertical piece. Mark and make the total length and width of the using portable power circular saw side vertical pieces. 220 into 560 into 19 mm, 4 numbers. Mark and make the total length and width of the half white sunmica. 225 into 565 mm, 4 numbers. Bond the sunmica on inside surface of the vertical side pieces using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmica edge using power planner and check the dimension. Top horizontal piece. Mark and make the total length and width of the plywood top pieces of the wall unit. 280 into 800 into 19 mm, 2 numbers. Mark and make the total length and width of the half white sunmica. 285 into 805 mm, 2 numbers. Bond the half white sunmica on inside surface of the top piece using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmica using edge portable power planner and check the dimension. Bottom horizontal piece. Mark and make the total length and width of the bottom horizontal pieces of the wall unit cabinet. 220 into 800 mm, 2 numbers. Mark and make the total length and width of the half-white sunmaker size. 225 into 805 mm, 2 numbers. Bond the half with white sunmaker on inside surface of the bottom pieces using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmaker edge using power planner and check the dimension. Middle horizontal piece. Mark and make the total length and width of the middle horizontal pieces of the wall unit cabinet. 220 into 760 into 19 mm, 2 numbers. Mark and make the total length and width of the half-white sunmaker both sides. 225 into 765 mm, 4 numbers. Bond the half-white sunmaker in both surface of the middle horizontal pieces using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmaker edge using power planner and check the dimension. Door piece. Mark and make the total length and width of the door pieces of wall unit cabinet. 400 into 580 into 19 mm, 4 numbers. Mark and make the total length and width of the cutting in glass as per dimension using portable power jigsaw machine and portable power circular saw in 2 numbers of door pieces. Mark and make the total length and width of the half-white sunmaker. 405 into 585 mm, 4 numbers. Bond the half-white sunmaker inside surface of the door pieces using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmaker edge using a power planner and check the dimension. Now let us see the preparations needed for making the material as per cabinet layout and check the dimensions for kitchen base unit. Task 2. Kitchen base unit cabinet material. Back horizontal piece. Mark and make the total length and width of the back side horizontal piece of the kitchen base unit cabinet using portable power circular saw machine. 2100 into 750 into 19 mm, 1 number. Mark and make the total length and width of the half-white sunmaker using sunmaker cutter. 755 into 2105 mm, 1 number. Bond the half-white sunmaker on inside surface of the back horizontal piece using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmaker edge using a portable power planner and check the dimensions. Top horizontal piece. Mark and make the total length and width of the top horizontal piece of the kitchen base unit cabinet. 575 into 2100 mm into 19 mm, 1 number. Mark and make the total length and width of the half-white sunmaker. 580 into 2105 mm, 1 number. Bond the half-white sunmaker in inside surface of the top horizontal piece using Fevicol SR. Allow the Fevicol to dry. Plane the excess sunmaker edge using power planner and check the dimensions. Bottom horizontal and vertical piece. Mark and make the total length and width of the bottom horizontal and vertical piece using power circular saw. 540 into 2060 mm, 1 number, horizontal piece. 76 into 2060 millimeter, 1 number, vertical piece. Mark and make total length and width of the half white Sanmaika. 545 into 2065 millimeter, 1 number. 100 into 2065 millimeter, 1 number. Bond the half white Sanmaika on the inside surface of the bottom horizontal piece using Fevicol SR. Allow the Fevicol to dry. Plane the excess Sanmaika edge using portable power planner and check the dimensions. Side vertical piece, plank. Mark and make the total length and width of the side vertical piece of the kitchen base unit cabinet. 730 into 520 millimeters, 2 number. Mark and make the total length and width of the half white Sanmaika. 735 into 525 millimeter, 2 number. Bond the Sanmaika inside surface of the side vertical pieces using Fevicol SR. Allow the Fevicol to dry. Plane the excess Sanmaika using power planner and check the dimensions. Middle vertical piece, plank. Mark and make the total length and width of the middle vertical piece of the kitchen base unit cabinet. 520 into 634 millimeter, 3 numbers. Mark and make the total length and width of the half white Sanmaika both side. 525 into 640 millimeter, 6 numbers. Bond the half white Sanmaika in both side surface of the middle vertical piece using Fevicol SR. Allow the Fevicol to dry. Plane the excess Sanmaika using power planner and check the dimensions. Door piece, plank. Mark and make the total length and width of the door pieces of the kitchen cabinet. 400 into 660 into 19 millimeter, 2 numbers. 390 into 660 into 19 millimeter, 2 numbers. Mark and make the total length and width of the half white Sanmaika. 405 into 665 millimeter, 2 numbers. 395 into 665 millimeters, 2 numbers. Bond the half white Sanmaika on inside surface of the door pieces using Fevicol SR. Allow the Fevicol to dry. Plane the excess Sanmaika, etch using a power planner and check the dimensions. Basket front piece, plank. Mark and make the total length and width of the basket, front piece of the kitchen cabinet. 150 into 520 into 19 millimeter, 1 number. 200 into 520 into 19 millimeter, 1 number. 310 into 520 into 19 millimeter, 1 number. Mark and make the total length and width of the half white Sanmaika. 155 into 525 millimeter, 1 number. 205 into 525 millimeter, 1 number. 315 into 525 millimeter, 1 number. Bond the half white Sanmaika on inside surface of the basket, front pieces using Fevicol SR. Allow the Fevicol to dry. Plane the excess Sanmaika, etch using a power planner and check the dimensions. In this topic, we have learned how to achieve precise dimensions by cutting cabinet materials accurately, minimizing errors and optimizing material utilization. Follow the kitchen cabinet plan carefully, making sure all parts fit together smoothly for a neat and good looking setup. Cut materials to specified dimensions, minimizing waste and promoting cost-effective production. Implement thorough checks to verify dimensions, identifying and rectifying any discrepancies in the manufacturing process. I hope you all understood the process of making the material as per cabinet layout and check the dimensions. Thank you students, and let us meet in the next session. Bye. Hello students. Welcome to this trade on woodwork technician carpenter. In this session, we are going to learn about structuring the kitchen cabinet and finally finishing with sunmaker and hardware. In this trade, we are going to build and set up a kitchen cabinet step by step. First, we will assemble the frame to give it a strong structure. Then, we will make it look nice and lasting by putting on a layer of sunmaker. Finally, we will add the hardware to make sure the cabinet works well and looks good in your kitchen. Objectives: we aim to build the kitchen cabinet by putting together its frame. After that, we want to make it look nice and durable by adding a layer of sunmaker. Lastly, we will attach the hardware to make sure the cabinet works well and looks good. By the end of this exercise, you will be able to construct the cabinet frame, assemble and put it together, apply the sunmaker to bond and finish the surface, install the hardware onto the cabinet, inspect the cabinet frames for any damage. Now let us see the preparations needed for structuring the kitchen cabinet and finally finishing with sunmaker and hardware. Assembling the cabinet wall unit frame. Check the side vertical pieces, top horizontal piece, bottom horizontal piece and horizontal middle pieces. Back piece of the cabinet to the required measurement before assembling. Prepare the electric screwdriver on screwing. Set the bar clamp to assemble the wall unit frame. Apply the Fevicol on side vertical pieces edge surface. Assemble the top, bottom and side vertical pieces, horizontal piece and back piece. Mark the drill hole point on the middle of the edge. Place on the bar clamp with wooden support pieces and tighten it. Mark the pilot hole on the marked points of the edge. Insert and drive the Phillips flat head screws using electric screwdriver. Smooth all the surface using portable power disc sander. Mark and make total length and width of the color sunmaker of the cabinet, wall unit frame top, bottom vertical sides and middle of the back piece. 802 into 302 mm is equals to top pieces, 2 numbers. 802 into 242 mm is equals to bottom pieces, 2 numbers. 242 into 602 mm is equal to vertical sides, 4 numbers. 502 into 602 mm is equal to back front middle, 1 number. Bonding the color sunmaker on face side of the top, bottom, vertical sides and back middle using Fevicol SR. Bonding the edge, bonding tape on wall cabinet unit, frame on all front edges using Fevicol Heatex. Door finishing. Check the dimension of the wall, unit cabinet, door pieces Mark and make the total height and width of the color sunmaker of the door pieces. 402 into 582 mm is equals to 4 numbers. Bond the color sunmaker on face side surface of the 2 numbers of door pieces using Fevicol SR. Repeat same procedure. Bond the color in mica one face side surface of the glass door. 2 numbers. Remove the sunmaker covering the glass finishing open cutout. Filling the excess sunmaker with hand file and finish glass doors. Bond the edge banding tape on doors all edges using Fevicol Heatex. Select and set the hinge boring drill bit in portable power drill machine on door ring. Mark and make the hinge boring on the marked points of the door. Press the hinge in place once the recess base is completely flat. Make a pilot hole through the hinge hole to fix the screw. Insert and drive the suitable screws in all holes using electric screwdriver. Mark and make the hole through the handle hole to fix the screw. Set the handle on the door front side. Check the handle shake. Check the glass size is equals to 300 into 480 mm is equals to 2 numbers. Mark the position of the glass corner holder hole to fix the screw. Set the glass and corner holder door inside 4 corner. Fix the screw through the screw hole. Check the alignment of glass. Door fixing in wall unit cabinet. Mark the hinge position on cabinet frame after making the cabinet door. Transfer the cabinet door hinge position on inside of the cabinet frame. Mark a recess on cabinet frame to fix the hinges as explained earlier. Screw the hinges to the cabinet frame using screw in the center of each leaf after making the pilot hole. Check the alignment of the cabinet leaf. Check once again the fitting of cabinet door. Mark and make the pilot hole through the magnetic catch hole to fix the screw. Set the magnetic catch on the cabinet frame top and bottom in position. Check the free movement of cabinet doors. Finish the modular kitchen wall unit cabinet. Task 2. Kitchen cabinet from base unit. Assembling the kitchen cabinet frame base unit. Check the side, middle vertical pieces, top bottom and horizontal pieces. Horizontal middle pieces and back pieces of the cabinet to the required measurement before assembling. Set the bar clamp to assemble the top and bottom of the frame. Apply the Fevicol all surface. Assemble the top, bottom and side, middle vertical pieces, middle horizontal pieces and back pieces to make a frame and mark the drill hole point on the middle of the edge. Place on the bar clamp with wooden support pieces and tighten it. Make the pilot hole on the marked points of the edges. Insert and drive the Phillips flat head screws using electric screwdriver. Check the squareness of the cabinet frame. Mark and make the total length and width of the top pieces, cutting into sync as per dimensions using portable power, circular saw and portable jig machine. Check the squareness of the cabinet frame. Mark and make total length and width of the color sun mica. of the cabinet frame, top horizontal piece, side vertical pieces and bottom vertical pieces. 602 into 2100 millimeter is equals to top piece 1 number. 100 into 2100 millimeter is equals to bottom vertical piece 1 number. 752 into 542 millimeter is equals to side vertical pieces 2 numbers. Bond the color Sunmaker on face side of the top, bottom, vertical sides using Fevicol SR. Remove the Sunmaker covering the sink fitting open cutout. Filling the excess Sunmaker with half round file and finish the sink cutting. Bond the edge bonding tape on the kitchen cabinet frame on all front edges. Check the dimensions as per drawing in the base unit cabinet. Press the hinges in place once the recess base is completely flat. Make a pilot hole through the hinges hole to fix the screw. Insert and drive the suitable screws in all holes using electric screwdriver. Mark and make the hole through the handle hole to fix the screw. Set the handle on the door face side. Check the handle shake. Basket finishing. Check the dimensions of the kitchen cabinet basket front pieces. Mark and make the total height and width of the color Sunmaker of the basket pieces. 525 into 155 millimeter 1 number. 525 into 205 millimeter 1 number. 525 into 335 millimeter 1 number. Bond the color Sunmaker on face side surface of the basket pieces using Fevicol SR. Bond the edge banding tape on basket pieces edges using Fevicol Heatex. Mark and make the basket hole on the marked points of the pieces to fix the screw. Set the basket on the basket piece inside. Check the basket shake. Door and basket fixing and cabinet finishing. Mark the hinge position on cabinet frame after making the cabinet door. Transfer the cabinet door hinges position on inside of the cabinet frame. Mark a recess on cabinet frame to fix the hinges as explained earlier. Screw the hinges to the cabinet frame. Screw in the center of each of after making the pilot hole. Check the alignment of the cabinet leaf. Insert suitable screws in all after making pilot holes. Check one again the fitting of cabinet door as per the drawing. Mark and make the pilot hole through the magnetic catch hole to fix the screw. Set the magnetic catch on the cabinet frame top in position. Check the free movement of cabinet doors. Mark and make the pilot hole through the sliding rail hole to fix the screw. Set the sliding rail on the basket and cabinet frame middle vertical piece inside in position. Insert the basket in cabinet frame sliding rail. Check the free movement of cabinet baskets. Finish the modular kitchen cabinet base unit. Recap. In this topic, we have learned how to construct the cabinet frame, assemble and put it together. Apply the Sunmaker to bond and finish the surface. Install the hardware onto the cabinet. Inspect the cabinet frames for any damage. I hope you all understood the process of structuring the kitchen cabinet and finally finishing with Sunmaker and hardware. Thank you, students, and let us meet in the next session. Bye.
Good morning, ladies and gentlemen. In recent days, you would have seen that 3D printing as a form of rapid construction technology has picked up a lot of imagination and a lot of traction. Now, in the course of next 10-20 minutes, we will try to understand the basic elements of 3D printing, how it is currently being used, although in nascent stages, how it is being used abroad, and how best we in India can build upon the traction that has already been gained. So, attending the session with me, to my right, is Professor Manish, Professor from IIT Gandhinagar of Civil Engineering, who has been taking a keen interest in such technologies, especially in 3D printing, and he has been mentoring students. And to my left is Sri Shashank. Mr. Shashank is the IIT Gandhinagar sponsored or IIT Gandhinagar guided startup, MyCab. He belongs to that startup. He hates that startup. It's a teamwork, to be precise. However, he is the primus inter pares who is trying to run the show. Now, in addition, from IIT Guwahati, we have requested the presence of Dr. Panda, a professor who has again been taking keen interest in 3D printing. Having said so much, let us move on. Professor Manish, sir, we have got so many technologies like MyOne technology. If I understand, a technology where shuttering is already provided in situ and you try to force feed concrete and that concrete spreads into all the crevasses and fills it in form, and then it takes the shape of a building, and the moment it is set, the same shuttering material can be used repeatedly for a number of times. And that is one particular technology that has caught the fancy of Indian construction industry in times nearby. However, today we are talking about 3D technology as a new technology that is catching the imagination of many. Could you say as to why you feel 3D technology is the rising star in rapid construction?
Thank you very much, Brigadier Muthukumar. And it is my pleasure to be here, and very good morning to the audience. And 3D concrete printing technology, let me just tell about the basics of how it works. So basically we have a 3D printing setup that can be robotic, that can be gantry based, and we pass a cementitious material through that system, and that basically produces the material layer by layer in a way that it gains sufficient strength immediately after being printed, and it is able to support the layers that are being printed above it. Now, the process basically is attractive because it is automated and it is very fast. Here, if we look at it from the point of view of defense facilities, not just the overall construction scenario in the country, time is of utmost essence, and our construction, whether it is civil or whether it is defense, it gets affected significantly by factors that are sometimes in our control, sometimes not in our control. For example, if there is a natural calamity, we will not be able to complete our production on time thanks to the manpower issues, thanks to the supply issues. The world is undergoing substantial changes at this point as we speak, and the economy and many other factors, they impact our overall ability to be able to construct things in time, while at the same time India is needing a lot of houses, as also has been highlighted by the government of India and many state governments time to time. So basically, many of the lacuna that we come across in the conventional construction, that can potentially be mitigated by 3D concrete printing technology. This technology can be used to produce small pieces which can be joined together to make small houses. Those small pieces can be printed in the form of furniture. Those small pieces or somewhat larger pieces can actually be used as consumable or reusable formworks that will save a lot of time that actually goes into the erection of formwork. That technology is still emerging, and technology can actually help us get to a level where we can construct large buildings as well in one go in barely few hours. We are also looking at it from the point of view of climate. Here we are also looking at it from the point of view of aesthetics. Because it is automated, because it is machine control, it is very easy to come up with shapes that are very efficient in not just